us. Yeah, we're Project PHaEDRA. So PHaEDRA stands for Preserving Harvard's Early Data and Research in Astronomy. My name is Sydney Evans. I'm the Assistant Community Coordinator for Project PHaEDRA at the Walbeck Library in the Center for Astrophysics, Harvard-Smithsonian. And I'll pass it over to Katie to introduce herself.
Yep. Hi, everyone. I'm Katie Fry. I'm currently interim head librarian at Walbeck Library, and I work very closely with Sydney on Project PHaEDRA. So I'll go ahead and go to the next slide.
Yes.
All right.
So happy Women's History Month. Thank you for having us this month for that, because our project is very focused on women's history, and you'll see why. We're going to talk a lot about women astronomers. All right, so these are the women. So they're called the Women Astronomical Computers. So before computers were machines, computer was a title for people who did computational work. And at the Harvard College Observatory, the Women Astronomical Computers, this group name is, they studied detailed photos of the night sky to make really valuable discoveries in astronomy and astrophysics. And as you can see, there's an image here of the women. A few of the more famous ones that we'll talk about are in this image as well. So they did a lot of computational work. You've probably heard of computational work being done at NASA or NACA, but it was also being done at Harvard to study the sky. So we're going to talk a lot about the astronomical photographic glass plates. This is a collection that Harvard has at the Harvard College Observatory. It is the largest collection of astronomical glass plates in the world, and there are 550,000 glass plate negatives and spectral images, more than that, in the collection. And it has a history of women studying and curating the collection. The collection makes up a century of irreplaceable images and scientific observations in both the northern and southern hemispheres. And hundreds of women studied and curated the plate stacks. They also made discoveries of their own, but their work was not often as recognized, unfortunately. And here is an image of a plate, a photographic glass plate.
Yes, this is actually plate B2312, and we will be bringing that back up again a little bit later in the presentation. So yeah, I just wanted to talk a little bit about a few of the women that we're highlighting that worked at the observatory in the 1800s and even early 1900s, and really made substantial contributions to the science of astronomy. So first of all, we have Henrietta Swan Leavitt. She developed the period luminosity relationship, which is now known as the Leavitt law. And this was used to help calculate how far away stars and galaxies are from us. So what she did is she would look at these photographic glass plates of stars, and she would look at two plates of the same area of the sky, and she'd look at different stars and see that, okay, this star over here is a certain brightness on this plate, but the same star on the other plate is much brighter. And then she'd look at another one and see that it got dimmer again. So it's the exact same star, and it's getting brighter and dimmer over time. What she ended up discovering was this particular class of variable stars called Cepheid variable stars. And these stars actually get bigger and brighter over time, and then they start to shrink and get a little dimmer over time. And they go through this very steady variability, getting brighter and dimmer and brighter and dimmer. And she also figured out that the slower that this transition happened between the brightest points and the dimmest points of the star, that meant that when it was at its brightest, it was very, very, very bright, brighter than similar stars that went through that variation a lot quicker. So the faster it pulsed, the brighter it got when it reached its maximum brightness. And this became really important because, when you're looking at the night sky and you see a bunch of stars, you might see a star that looks very faint. But in reality, that star could actually be intrinsically incredibly bright, but just very, very far away. And you might see a different star that looks really bright on the night sky, but it just happens to be a faint star that's actually really close to us. So, the brightness that we see is a factor of how bright the star actually is and how far away it is from us. So once you begin to understand that there's this one star over here that's pulsing very slowly, but it looks dim, and there's another star over here that's pulsating quickly and it looks bright, you actually know that that dim star is actually inherently incredibly bright, which means it's very, very far away, right? So she really started to understand just the vast scales of the universe, how far away these objects are from us and from each other. And that's just one of those very fundamental pieces of astronomy, is just knowing how far away things are from us. And so she started kind of that yardstick, as they call it, for the night sky. The next woman I wanted to speak about today is Cecilia Payne-Gaposchkin. She was actually the first person, not only the first woman, but the first person to get a PhD from Harvard University. There was no astronomy program at Harvard before she started there. Most people studying this topic went through the Harvard physics department, but they would not grant a woman a PhD. So Harvard created the Department of Astronomy, basically so that she would be able to earn her PhD. And she got that in 1925. And her stunning discovery was that the stars are made mostly of hydrogen. Before her time, the prevailing theory was that stars are made out of the same stuff, relatively, at least, as the planets. They just thought it was much hotter, but it was basically silicon, carbon, the same kind of stuff as Earth. But she said that, radically, that stars are actually made mostly of hydrogen and helium. And in fact, the idea was so radical that her own thesis advisor made her add a sentence to her thesis saying that she was she's like, I'm almost certainly incorrect about this, but this is what I found. And we found out a few years later through other means that indeed she was 100% correct. What she did was looked at the spectrum of stars. So when you pass light through a prism, you see a rainbow, right? And when you have it coming from a star, so the light from a star comes from the nuclear fusion happening inside the center of the star, and then the light energy passes through the atmosphere of the star. And different elements in the star absorb different wavelengths of light. So the spectrum you get is kind of like in this picture, we have different absorption lines. And by studying what the absorption lines are and studying chemistry, you can understand which elements are present in the atmosphere of that star, in kind of the outer shell, or the large portion of the star. And so the hydrogen and helium lines were quite dark, which meant a lot of that wavelength was being absorbed. And that led her to declare that hydrogen and helium were the most abundant elements in stars, and therefore the most abundant element in actually the universe. And again, that was radical at the time, and that was her doctoral thesis. All right, let me go on to Wilhelmina Fleming. I'll pass it to Sydney.
Yeah, so I'm going to talk about Wilhelmina P. Fleming. So she came up with a stellar spectra classification system, and she cataloged and identified more than 10,000 stars, nebulae, variable stars, and novae. She was also named the first curator of astronomical photographs in 1898 and was overseeing her fellow women computers. And this was the first time a woman was appointed a professional position at Harvard. So it was a very big deal that she was given this position. She identified the variable stars and cataloged them using the same type of system that Katie explained, by comparing between plates and noticing the brightness and dimness. Yeah, so we can go to the next slide. So this is that plate that we had earlier in the presentation, plate B02312. This is the plate that Wilhelmina P. Fleming used to discover the Horsehead Nebula in 1888. So with these two images, you can see on the right, there's a zoomed out picture of the plate, and on the left is a close-up. And in this little circle, you can see a small semicircular indentation, and that is the shape of the Horsehead Nebula that Wilhelmina P. Fleming identified. And it's very, very small. So you can see just how extraordinarily detailed this work was in observing the plates and identifying these small differences. And they had different equipment that they used to identify it, such as these small things called fly spankers and these different setups for observing the plates. But we won't talk as much about that. But they had a lot of cool gear that they used to identify the items. Yeah, and I'll also talk about Annie Jump Cannon, who's another really famous woman astronomer from this group. So she was instrumental in developing the contemporary stellar classification for temperatures and spectral types. And here we have a Hertzsprung-Russell diagram, which explains that relationship between stellar luminosity and spectral class, which she laid the foundation for with her discoveries. She was also named the curator of astronomical photographs in 1911, just like Wilhelmina P. Fleming was. And here in this image, you can see her using a telescope. So the women at the Harvard College Observatory were not usually allowed to use the telescope. There were some policies against that. But the Harvard College Observatory had another observatory in Arequipa, Peru, and she was able to use the telescope there, as you can see in this image.
Yeah, I'll just jump in and add that they weren't allowed to use the telescopes and make their own observations, but they did have unlimited access to these astronomical photographic glass plates. And something that's interesting is, when you're looking through a telescope, you have to rely on your natural eye's own refresh rate, and you refresh about like 60 frames per second. So a lot of monitors have that kind of refresh rate because that's what you see it as. But when you're looking at a photograph, a glass plate, the exposure time of that can be minutes, can be hours even. So you're able to collect more light, whereas your eye can only collect so much light, and it does it 60 times a second. It collects light and then it refreshes and collects a new batch of light. On a plate, you're getting all that light constantly. So you can actually see more detail of the night sky looking at a glass plate than you can through the telescope. So they had that advantage at least.
Yeah, so even though they weren't using the telescope, they were still able to make these incredible discoveries using the plates.
Yeah. So these 4 women that we highlighted are just a few of the many women that worked at the Harvard College Observatory. They are also 4 of the most well-known ones. And as we kind of described, they really did lay the foundation for modern astronomy. They helped us figure out how far away stars are, what stars are made out of, how to describe different types of stars, and how do we begin to understand how stars change and evolve over time. Those are all topics that modern astronomers are still grappling with and still trying to get the finer details of. And that work really started here at the Harvard College Observatory in the 1800s. But unfortunately, as we mentioned earlier, they were not often given proper recognition for their work. Their scientific discoveries were shared in articles and research papers at the time, but they were usually published under the names of the male astronomers, as they were simply the women computers at the time. The articles did frequently mention these women by name within the text of the article and did credit their work within the article, but their names did not appear as authors. So when someone was citing that paper for another discovery, you would cite this astronomer's name and not the women who actually did that work. So beyond seeing their names mentioned in these scientific articles of the time, how else do we know that they did work? They did this kind of work? Well, the photographic glass plates, many of them have markings, handwriting on them. The plate would have emulsion on one side and would be a clear plane of glass on the other side that you could actually write on. Then the women would wipe their markings down and then write other things on it as they were doing their work. But we still have many plates in our collection where the handwriting remains visible today. They were actually fairly well known during their time. There were many newspaper articles and communications describing their work, such as this one here, which kind of talks about what I said earlier about how these people were able to study astronomy and no longer needed to actually see the night sky at night in order to do that work. And what we're really here to talk about today is the research notebooks that they left behind. We have over 2,500 of these research notebooks. These are where they did their work. They did calculations. They jotted down what they were seeing on the glass plates. We have this collection of research notebooks that really prove the work, and it shows the work that they did. And it's also kind of cool to think that, scientists today still use notebooks similar to what these women computers did to track their research and scientific process. It's a tradition that they took part in. It's a tradition that still holds today for scientists. So as I said, we have 2,500 notebooks, and our Project PHaEDRA, Preserving Harvard's Early Data and Research in Astronomy, is all about making that information public, making it accessible. One of the things they've done is digitize the notebooks, and they're all online right now on our website. You can just download the PDF for each of these notebooks. And really this information it's irreplaceable. It's something, if it's gone ever, we can't ever go back and redo what these women did in their work. And our efforts for Project PHaEDRA have really been very collaborative. So we initiated it at Wolbeck Library, but we worked with the Harvard Plate Stacks, because they had the notebooks in their collection originally. We've worked with Harvard Imaging Services to get them digitized, the Weissman Preservation Center to make sure that the notebooks will last as long as they can. We've also partnered with Zooniverse and the Transcription Center, which we'll talk about in more detail later. So again, one of the first steps was digitizing the notebooks. This is just a photo that we took when we got to tour the Imaging Services lab while they were working on our notebooks. And we've since imported most of these images to these different citizen science platforms like the Transcription Center and Zooniverse.
All right, so as Katie said, we have digitized the notebooks and uploaded the images to different citizen science websites. So we have the Smithsonian Transcription Center, which we work with as well because they're part of our organization. So on this website, I don't know if you guys have heard of it or have worked on it before, but it is a transcription site to fully transcribe text of documents. So we have uploaded the notebooks to the site, and volunteers are transcribing all of the text on the pages. And we have a link here to how you can access it. You can also search for Harvard Smithsonian Center for Astrophysics on the Smithsonian Transcription Center. So this task can be somewhat challenging because the content in the notebooks varies so widely, and there are a lot of different inclusions such as graphs, diagrams, tables, symbols, and other features that require unique formatting. But it's all extremely valuable, and to have all of that preserved as it was written as easily as we can so that it can be searchable, because that is the ultimate goal of the Transcription Center. Yeah, so eventually we want the notebooks to be full text searchable on the Astrophysics Data System. So the Astrophysics Data System is the premier source for professional astronomical literature. If you're an astrophysicist or an astronomer looking for research, your search typically starts and ends at ADS. That means if an astronomer is looking for literature about a star that one of the women astronomers studied, her notebooks would be full text searchable, and you could search for that star and find it in the notebook. And it would appear alongside the image of the notebook, so you have both of those at once to compare. Yeah, the notebooks will appear alongside modern research when they come up on the Astrophysics Data System. So it's extremely valuable to have all of the keywords and terms and text transcribed, as well as the numbers and tables, just so we have all of the data and all of the raw material that they worked with, so that it can be searched just like any other document online. Our other project is called Star Notes, and it's on Zooniverse, which you also may have heard of. It's also a citizen science site. And this is a bit different from the Transcription Center because the project is focused on classifying the content instead of transcribing everything that's on the page. We're just giving volunteers a prompt for something to search for in the notebooks, and then identify that, and then classify it by a short list of terms we have, and then move on to the next page and classify again. So this one is a lot quicker than the transcription center because you're just looking for something, boxing it, and then moving on. And the good thing about Zooniverse is that it also has a talk boards function where volunteers can discuss the things that they found or ask questions about the task, which is really great. And my job is often to be on the talk boards and interacting with volunteers and seeing what they found. Yeah, and we can go to the next one.
Okay.
Thank you. So the first phase of the Zooniverse project was to identify glass plate identifier numbers. So these are the numbers that correspond to the glass plates. So when an astronomer used that glass plate, they would usually write it down because they're working with all of those. And yeah, there's a lot of glass plate numbers in the notebooks. So what we were trying to do is have volunteers identify those numbers, and then we would be able to cross-reference the plate that was used for that page and for that discovery or whatever was done on that page. So that was the first phase, which we have completed. It was really awesome that we finished that. So the second phase that we're doing now asks volunteers to classify non-textual features in the graphs, in the notebooks, such as graphs, images, diagrams, inserted papers. And this is really interesting because there's also things like doodles and inserted historical newspaper clippings and things like that, and stamps, different things that volunteers are identifying. So this image is an image of doodles of aliens on Saturn, which is just one of the really cute, fun things that you can find in the notebooks. Yeah, so how can you get involved with our project? So as we've talked about, you can classify on Star Notes on Zooniverse. You can also transcribe on the Smithsonian Transcription Center. You can sign up for our PHaEDRA newsletter, which we talk about all of the projects that we're currently doing, and we usually will mention our office hours, which we have office hours programming. We've been doing it monthly, but we may change our schedule a bit. So you can just, if you want to hear about those, you can sign up for the newsletter, and we usually give updates on those. You can also read these really awesome biographies about the different women that were made by the PlateStack staff, and they are available on our website. And they have details about each astronomer, and it's a long list, and there's a lot of really interesting women to read about and to see what they discovered.
So yeah, that's a brief overview of you know, what the project is and kind of the history behind it, and why we find it to be so important and so valuable. Yeah, thank you for your time and attention. We'd love to hear if you have any questions. We could try to bring up some other examples if people like to see that. We just want to leave a lot of, you know, some time for that. And please feel free to reach out to us at our email addresses, which are on the screen, or our social media. We have an Instagram and a Twitter account. They're both Project PHaEDRA.
Yeah, and we usually post about upcoming office hours, like this event, or interesting finds that volunteers have found in the notebooks, different things about the project that we post on the social media.
This is wonderful. Maybe we can all come back together, Sydney and Katie, and we can do Q&A. And I know that Al was on early, and I know that he's one of your volunteers. Or do you have any other volunteers on here? Maybe they want to say a few words about what their experience has been.
Irene is on.
Yes.
Hello. I'm a volunteer at Star Notes on Zooniverse.
Welcome, Irene. How's the experience been for you?
It's been fun. Lately, I've been looking for non-textual material, and I began on Star Notes looking for text. I've been doing it for a few years.
Wonderful. And what interesting things have you found?
It's nice to see old data coming from someone who's interested in stars.
Yeah, that was going to be my next question. Do you have to, and this goes for Katie and Sydney, do you have to have a background in astronomy in order to look at these kind of technical documents and make sense of them?
No, I don't think you have to. I mean, I think maybe it might it might, you might maybe change your appreciation of it, I guess, a little bit, but you know, it is technical, but a lot of it is just kind of looking through it and kind of understanding the patterns of what the women computers were doing. You'll often see that, like, you know, Annie Jump Cannon had a certain style of writing, and that I think is really interesting to see that come out, as opposed to like Henrietta Leavitt and her style and her way of doing her notebooks. And I think that, you know, especially because Zooniverse does have these talk boards, it's a nice platform to kind of point out interesting things and get some other volunteers can kind of pipe up and say, oh, I found something just like that, or that's really cool and really unique and different. And then, like Sydney said, you know, they monitor that and kind of jump in as well and provide guidance. But yeah, I think through our office hour sessions, and we do have most of them recorded up on YouTube, we do try to kind of give that grounding and background in astronomy and also what the women astronomical computers were doing. So I think that helps as well. But no, I don't think you need to have it. You know, just need to have an interest and a passion for helping that for these, you know, helping make these women's contributions accessible and bringing them to light in a way that they hadn't been before.
And that's interesting. So you can tell from their notes, do you get about their different personalities?
Yeah, sometimes. I feel like you learn their handwritings, you learn the way that they make notes about certain things, the way that they abbreviate different things. You can learn a lot about their personality and their history just from going through the notebooks in detail like that. So it's a really awesome experience. I've really enjoyed the work that I've done at the library working on these notebooks.
Also gives you a look at how things were done in the past. Several times I've seen little notes at the bottom of the page. I have to stop because it's getting dark. They were using the light from the window to backlight the plates and do their measurements.
Yes, they're very like influenced by the time and technology that they lived in, you know. And something else I was thinking about when you asked about personality, you know, it's interesting and maybe kind of an artifact of the time, but you know, we also in this collection we do have some of the notebooks and logbooks are written by the male astronomers of the day. And in fact, that doodle we showed at the end was by one of them. So I didn't get their name. I should have thought of that ahead of time. But and it's kind of interesting to see that the women astronomical computers really took their jobs very seriously. I think that they realized how important and unique and rare it was at the time for them to be able to have this kind of scientific work and to be contributing in the scientific way. Not that the male astronomers didn't, you know, feel that as well, but their notebooks often have more doodles and more drawings as well. And again, a lot of their notebooks were at a telescope and drawing what they see. They kind of predate photography, so their work is less precise because of that, and it's more based on what they believe they're seeing. But you really can't do science on that. While the women's notebooks are typically, you know, tables of data or calculations where they'll have like a starting number, and then you can see like for like a bunch of stars listed with like a starting brightness, and then they have like a calculation on the next column and another calculation on the next column as they're trying to figure out, you know, what is the actual brightness of the star compared to what they can see it on the on the plate. Excuse me.
And how you said that you had, I can't remember the exact amount, 2,500 or so of these notebooks, and how far were you into the project, and do you see an end date in sight? And I know that you're actively looking for more volunteers to get involved in transcribing.
Yeah, it is definitely a big project. I had previously estimated that we were getting only like 1 or 2 notebooks a month, but I actually think that number is lower than what we've actually been getting. I think we've been on the transcription center since like 2018, and we've gotten, I think, about 300 notebooks transcribed, but we still have 2,200 to go. So it's going along at a really good clip, a really good pace, the transcription. So this is the full transcription of every single page and all the writing on every page. And we have times like Women's History Month where, you know, there's a lot of engagement because people want to work on these notebooks, or specifically our women astronomical computers. And then we'll have times where the engagement's a little lower, which is fine. You know, it's interesting to see that ebb and flow over time. And it is really exciting that we've gotten so many notebooks completed. So it really, it's really making it exciting for us to move on to the next stage, since we have so many done. Like Sydney was saying, is to put that full text into the astrophysics data system so that people can actually search for stuff in those notebooks. Now that we have so many, it's time to really start moving forward with that.
So, my question just blew out of my head. Does anybody have any questions? Yes, Crystal.
Sorry, hard to unmute there for a second. Yeah, I'm really curious to know if you've tried using artificial intelligence to automatically recognize any of the content of the notebooks.
No, that's a really good question. We haven't officially started anything like that, but we are in contact with a company that does that. They've done a short demo on a couple of notebooks to kind of pick out words. And it does look pretty good, but we're going to see how it goes. I mean, one of the issues is that this is all handwriting, and sometimes it's in pencil, right, for the most part. So it's a little bit faded, a little bit hard to see. The handwriting varies notebook to notebook, but there is interest in that because, you know, handwriting can be pretty stable for one woman, but from one woman to the next, there's a lot of changes. So it's just going to have to take a lot of investigation. And having these transcribed notebooks that we're already getting from volunteers really help that along.
All right, great, thank you.
It's kind of interesting. It's a continuum. You know, you feel like you're actually doing what the women were doing at the time. I mean, you're right there next to them, in their brains and in their hands, and that's really quite special. Any other questions? Raise your hand, or you can put it in the chat box. Do people tend to work on one notebook at a time, or do they switch?
So we usually have up to 6 notebooks on the transcription center at a time, and volunteers can just switch between them whenever they feel like. They can switch between either transcribing or reviewing other transcriptions, so you can do either one of those things. So there is some variability on what you can decide to do. Right now, I believe we have Wilhelmina Fleming, maybe Evelyn F. Leland on the transcription center, and we also have a special collection of notebooks. It was about 4 notebooks of observations made by the women astronomical computers at the Maria Mitchell Observatory. So, which is a pretty interesting connection. So, because Maria Mitchell is also, if you've heard of her, famous American women astronomer. So, and some of the women astronomical computers were directors at that observatory, so it's pretty interesting. So yeah, sorry, that was a bit of a tangent, but anyways, that's what's on the transcription center right now. You can switch between different people and different content that way. And on Zooniverse, it's all of the notebooks at once, so you never know what you're going to get. So that's pretty exciting.
And how easy is it to get started as being a volunteer? Is there a process? Do you have to be vetted? Do you have to apply?
No, you can just you just have to make an account, I believe, on the site, and then you can go ahead and get started. And we have some instructions on both of them that can help you out. Right now, we're working on developing some more detailed instructions for the transcription center because those transcriptions are so detailed. So we've been trying to come up with more guidance for the different variations and all the different features that are need to be transcribed. So I would definitely say start with Zooniverse maybe, and then go over to transcription center. That's my personal recommendation.
Yeah, on the transcription center, just to give a little more detail, what happens is there's a couple of passes of the information, at least two. So the first person goes and you transcribe as much as you're interested in doing on a page, and if you actually complete it, do the whole transcription, you can mark it as complete. Otherwise, you can just leave the page incomplete, and another person can come in and try to finish the page. And then once it's been marked as complete, another volunteer comes through and reviews it. They look at the image again and the transcription and kind of take another, a fresh look at it to determine if everything's been fully transcribed. If not, they'll add more content, or they'll mark it as actually incomplete. And then another volunteer can come in and add content. And then if they deem it to be completely, fully transcribed, they mark it as reviewed. And then it goes to another level, which is us. We go through the pages and also verify the transcriptions. In some cases, we'll see a couple things missing, so we can make those quick edits. Or, as we were saying, there's handwriting and there's a lot of acronyms. And so we've seen a lot of that variation where sometimes our volunteers, maybe coming at a notebook fresh. And so we're able to kind of, provide guidance on what those acronyms mean or what the handwriting is actually saying as well.
I would say that, oh, sorry, Katie, go ahead.
No, go ahead.
I was just going to say, the volunteer community really helps us because the volunteers help each other out. And some of our volunteers are we used to be astronomers or are astronomers or know a lot about astronomy, so can offer guidance on the science, which is really valuable. So we're really thankful to all of our volunteers for everything that they've done to help us.
How many volunteers have you had working on the project?
I know that on Zooniverse, we've had 10,000, above 10,000 participants. So that's really great.
Yeah, I don't know the exact number on the transcription center, but it's quite high. We'll have some people who have done many, many pages, such as Al, who's here on the call. Thank you, Al. And sometimes volunteers come in and do one page and then we never hear from them again, which is also fine. So
is there a way that you can put the links to the two sites in the chat box so that people can easily click on them now and have them ready to go in their boxes? Okay, good.
That one's the transcription center. And now, Cindy, are you finding Zooniverse?
Yes, I can get the Zooniverse one.
Now, are both you, Katie and Sydney, actively transcribing?
Yeah, I mean, I have to say I have a day job, so I end up spending most of my time doing other work. But I have definitely transcribed pages. And I haven't done as much classifying on Zooniverse myself, but I do like to look at the notebooks and kind of work on that. And like I said before, part of what we do is the review on the back end to kind of finalize the notebooks as well. So
yeah, I would say I'm usually working on approving, but sometimes whenever I just want to try out the transcription to see what the volunteers are thinking and what their process is, I go and I will transcribe from scratch as well.
Wonderful. And are there any like I was mentioning before with the natural history collections, they're coming in and extracting new data. Are there any new findings that have been made with the information in the computer's notebooks?
That's a really good question. And I think that is something for the most part, we have to wait for astronomers to review the data, right? What we are discovering is that, their work processes were complicated and very detailed. And when you look at some of these pages, like you can transcribe it, you can read it, but kind of understanding the science behind it is kind of, there's a whole other task and a whole other thing to do. And so that's another reason we want to get these transcribed and machine readable, so we can actually build these tables like in Excel. We can transfer them there and then share them around and kind of get a deeper understanding of how they actually did their work. Because if you think about it, if you have your own notebooks for any kind of work you're doing, you understand the context of what you're writing, right? you understand kind of what you're intending, where it's going, how you got from point A to point B, but it might not be 100% documented in your notebook. And so we're finding that is the case. Yeah.
I just pasted some links in the chat, a link to sign up for our newsletter and more information, those bios that were written by the PlateStack staff about the women. They're really great.
And then you mentioned in the presentation that women weren't allowed to use the telescope. What was that about? Can you explain that?
Yeah.
Oh, go ahead, Sydney.
Oh, sorry. You go ahead, Katie.
Okay. So, I mean, it was, to use a telescope, you have to be out at night, and it's a little unseemly, perhaps. Maybe a little unsafe, maybe for sometimes, but I think it had to do with just the proprietary of it. Like, how would it appear if these women were out working late at night? More than anything else. Yeah.
Yeah, I'm working on a project right now where we are redefining the terminology for this group. So you may have heard us use women astronomical computers. So they used to be called the Harvard computers, but we're trying to use this other term now to greater describe the group. Yes, but I forgot what I was, oh yes. So in that group, we were talking about the telescope thing, and it was, yeah, what we discovered when we were doing research about it was that it was about the conditions outside and, unseemly being outside at night and like, basically like the fragility. It was, yeah.
Yeah. Some outdated notions.
Yes, okay. Any other questions about for Katie or Sydney or the other volunteers that are on here? I do hope that we can generate some more volunteers for you. I know that I'm going to be checking it out and getting my hands dirty, and I hope that others will follow suit.
Yeah,
awesome.
Thank you so much for letting us speak to everyone here. We really love Project PHaEDRA and we love sharing it. And sorry, rogue cat in the way here. The dangers of being at home. Yeah. But we really appreciate your time. And yeah, we'd love to answer any questions if you want to follow up with us on Twitter, Instagram, or on our emails. We'd love to hear from you.
Yes, definitely let us know if you have any questions. If you get started working on our projects and you need help, you can always email us or contact us on the talk boards. Yeah, we're here to help. And yeah, this collection is really incredible and we are really passionate about it. So.
Well, I am very grateful that you came and shared this with us, and hopefully get us very excited about getting involved. This was a wonderful way to celebrate Women's History Month, and now we all need to get out and connect and start looking at these women's notebooks and shouting it out to the world, all of the wonderful things that they were able to accomplish, and understanding more about our natural world from them. But thank you so much, everybody, for joining us on Must Learn Thursday. I hope I'll see you again next week when we do unmitigated gall wasps. Everybody's welcome. And everybody stay well, stay curious, and stay outside and get a telescope and go look at the sky, or just up at the moon and celebrate these wonderful contributions of these women. Thank you so much.
Thank you.
Good night, everybody.